A bus is an electrical path inside the computer system to transfer the data and information from one part of the to the other part. All devices are connected together through buses. It allows the CPU to communicate with all devices. The capacity of a bus depends on the number of data lines in it. The amount of data that a bus can carry at one time is called with bus width. For example, a bus with 32 lines can carry 32 bits or 4 bytes at a time. A bus with 64 lines can carry 64 bits or 8 bytes at a time. A higher bus width means that the bus can carry more data. It increases the performance of the computer. The speed at which data moves from one component to another component to the computer is called bus speed. It affects the overall performance of the computer. Bus clock Bus clock speed is measured in units to megahertz or millions of clock cycles per second. A computer may have three types of buses known as system bus, backside bus, and expansion bus. The system bus is part of the motherboard. It connects the processor to main memory. It is also known as front side bus. The backside bus connects the processor to cache. The expansion bus allows CPU to communicate with parallel devices. System bus. The the system bus is part of the motherboard. It contacts the processor to main memory. Different types of system bus are as follows: data bus, address bus, control bus. Data bus. Data bus is used to transfer data between different components on the computer. For example, it transfers instructions from memory to CPU for execution. It also transfers data between memory and the I/O during input-output devices. The number of lines in data bus affects the speed of data transfer between different components. A data bus with more lines can carry more data. A computer with 32-byte line data bus can transfer 32 bits of data at one time. A computer with 64 lines data bus can transfer 64 bits or data at one time. The data bus lines are bidirectional and can carry data to or from memory. Address bus. Address bus is used to connect the CPU with main memory to identify particular addresses in main memory. The number of lines in the address bus determines the amount of memory that can be directly addressed. A computer with a 32-bit address bus can directly address 4G to physical memory. The address bus is a unidirectional bus. It can carry information only in one direction. It carries address of memory location from CPU to the main memory. The newer computers are using a 64-bit address bus. Control bus. Control bus is used to transmit different commands from one component to the other component. For example, if CPU wants to read data from main memory, it uses control bus to send the memory read command to the main memory of the computer. The control bus is also used to transmit control signals like ASKS, acknowledge signals. A signal contains the following: timing information. It specifies the time for which a device can use data and address bus. Command signal. It specifies the type of operations to be performed. Suppose that CPU gives a command to the main memory to write data. The memory sends an acknowledgement signal to CPU. After writing the data successfully, CPU receives the signal and then moves to perform some other action. Some common commands are as follows: memory write. Write data to a given location in main memory. Memory read. Read data from a given location in main memory. Input output write. Write data to given output devices. Input output read. Read data from a given input device. Bus request. Request for a control on the bus for transmitting data. Bus grant. Indicate the grant of the bus to a device. Expansion bus. The buses that connect CPU to the parallel devices are called expansion buses. Expansion buses are typically 16 to 64 bits wide and are maintained on motherboard. These buses connect CPU to expansion slot on motherboard to which external devices may be connected. The expansion buses allows the processor to communicate with parallel devices attached to the card. Expansion buses provide faster transfer speeds and wider bit widths or higher data transfer rates to the many parallel devices. The common expansion buses include PCI and PCI Express buses, universal serial buses, and firewire.